You really try hard. Calculate the magnitudes of velocity VA and VP after the collision. Again, consideration in two directions, x and y. Y equal VA plus VB. The two balls have the same mass, huh? Two particles. Yeah, they didn't say anything about the mass, so assume that they are identical in mass. Okay, of each particle here. Oh, okay. Which is like the mass of a proton. Okay, identical masses, and then we can remove the mass from the equation of momentum. Calculate the magnitude of velocity VA VB after the collision. Okay, in the x direction, MVA cosine 60, yes, and MVB cosine 30, correct. And here, the upward positive, the downward negative, that's correct. Magnitude velocity VA VB after collision. Okay, calculating two things after collision. Elastically, okay, here. Yeah, it's a difficult problem. That's why you couldn't do it. That's normal, huh? Okay. To find the two variable, unknown variable VA and VB, we need two equations. One equation is a conservation of momentum, which means, do we know the initial speed? Yeah, 500. Yeah, which means conservation of momentum, huh? The mass of the particle, which is 1.67 times 10 to the power minus 27 kilogram, times the speed 500 meter per second. This is the initial momentum equal to the final momentum. The two components in the vertical direction cancel each other out. Only the horizontal component adding together and equal to the initial momentum. Okay, meaning that m times VA times cosine 60 degree plus this is the horizontal component. Okay, m times VB times cosine of 30 degree equal to initial momentum. And because the masses are identical, we can remove m from the equation. Okay, this is the first equation. Then the second equation is the conservation of kinetic energy, because this collision is elastic. So the kinetic energy after the collision is the same as the kinetic energy before the collision. Okay. So the second equation is 1/2 of the mass of the particle times 500 meters per second, the speed squared, equal to 1/2 of the mass of the particle A, which is identical with each other with the mass of the particle B, times VA squared, and then plus 1/2 m times VB squared. And again, we can remove m. Okay, so this is the second equation. You can solve this system of the equation using a graphing calculator to get the value of VA and VB. Solving it manually is all right. You can manipulate these two equations to find the solution, but it takes time. Do you have a graphing calculator?
No.
Okay. So can you try, okay, simplify these two equations and solve it manually. Like the following: cosine of 60 degree is the square root of 3/2, right? Wait, no, that's 1/2, huh? Okay, 500 on the right here, the left here. Cosine of 60 is 1/2, huh? 1/2 of VA. You can imagine VA here is like an X, and the other is a Y to simplify the calculation. Okay, VA, just VA. And then VB, cosine of 30 is square root 3/2, huh? VB. And then we can multiply 2 on both sides of the equation, making this 1000. And remove the 2 at the bottom, huh? Yeah. So we have the new equation, which is simpler, okay? And the equation at the bottom, again, 1/2, 500 square. 1/2, we remove the 1/2 as well. 500 square equal VA square plus VB square. Okay, representing one variable like VA in terms of VB from the first equation and plug into the second equation, substitution method. Okay, you can find the value of VA and VB. Okay, please solve this system and tell me the answer. Check it with the max scheme. I mean, I can use Desmos, for example, to get the answer, huh? Desmos or GeoGebra. graphing calculator. Okay. Or to save time, you just try solving the system later. Huh? I think you can do that, right? When using decimals, we simply just put in the two equations, VA, which is x, and then square root of 3 times VB, which is y. Right? Considering like x and y equal to 100, huh? That's the first equation, which is a straight line. The second equation, x squared plus y squared equal 500 squared, which is a circle, huh? There. Wow, there. So we have two solutions here and here. Oh, 1000. This one 1000, not 100. Sorry. 2 times of 500, 1000. Okay, change this thing 1000. The only solution here 250, 433. See, exactly the same with the answer. Okay, you got it? Yeah. Substitution method, huh? Representing one variable, substitution in terms of the other variable, plug into the second equation, and then you can solve for VA and VB. 250, 430 if we take two significant figures.